Okay, now we have to draw our own graph. Oh, they didn't give us a coordinate plane. That's okay. So we're going to find the area of the region created by the graphs of f of x equals x, g of x equals 8x, and h of x equals 1 over x squared. What in the world is that going to look like? Let's find out. Let's just start typing. So x, 8x, delete that stuff, and then 1 over x squared. And we're going to just graph them and see what happens. So zoom, standard window, just to kind of get a feel for what's going on here. And then we'll see where we need to zoom. Whoa, what's happening? I want to see the area, or find the area of the region created by the graphs of these three things. So where do these three things kind of come together and make a shape collectively? And it's a little convoluted, but if we were to zoom in right about here, we would see I use this word very loosely, a triangle. Basically, we're going to have a three-sided figure, and it's not truly a triangle because of this curve, but we have a three-sided figure, and each of the sides is a different function. So let's get it's not bitter. Let's get a better picture of it. I'm going to zoom in. I'm going to do a little trick here. I'm going to call it zoom box. Comes a boom box. We'll start around the origin. I like to go down a little bit, and then we will kind of box it in right there, and I'll just be able to get a better picture of what's going on. Now we know this line is y equals x. The red one is 8x, and the other one is 1 over x squared. And we need to figure out the area of this little thing. So we're going to draw it. It doesn't have to be perfect, but it does need to be well enough that we can figure out what's going on. So let's draw this thing. So there's that, and here we go. So we're going to have y equals 8x, which is really steep. So it goes, I'm going to be consistent with my colors on this one. Y equals 8x, this is g. And we're going to have y equals x, which is normally here, but we're scaling it a little bit differently. And it's, just to create whatever room. That's the blue one. And let's extend this a little further. And we also have 1 over x squared. And that is here. There we go. And what we really want to find is this area. Okay, well, how you want to do it? Well, I tell you what we need to do. We need to figure out what's on the top, what's on the bottom, where things cross, where my points of intersection are. We need to figure all this stuff out. And this is doable, calculator inactive, and we actually might when we get deeper into it, but let's not yet. So let's figure out a few things, and this one's going to be obvious. This is at 0, 0. I hope that's obvious. So whatever I'm going to start with when I'm trying to figure out the intervals I'm dealing with, 0 is my leftmost interval. And I have a rightmost interval, and it's here. And that, in case you haven't noticed, is at 1. And you can tell, you can look at your calculator and tell. So let's do it. So let's go to the calculator, and let's find a point of intersection. And I'm going to find this point right here. So what's my first curve? What's the blue one? What's my second curve? It's showing up to be the red one. I'm going to press an arrow button. Here we go. We'll go to the black one. Go down. And guess, well, you guess. There we go. 1, 1, which you kind of knew in a sense, because if you plug in a 1 here, you get 1. You plug in a 1 here, you get 1. So they meet. They meet. So this coordinate right here is at 1, 1. So this is at x equals 1. And I also need to know this point. Why do I need to know this point? Okay, well, let's go back to the very beginning of the lesson that I have stashed away over here. It's on the front of your paper, but it's on a separate piece of paper for me. And it says this. It says top minus bottom. All right, well, we have 3 curves going on, 2 lines and a curve. And so when I say top minus bottom, I have different tops and different bottoms on this problem. So here, let's grab some Post-it notes. Here we have, let's go colors. We have red minus blue. Red function minus blue function. Well, then it shifts. It changes. And so now it's black minus blue. So I can't just have one interval on this. I have to have 2. I'm going to go ahead and start writing out what I do know, and we'll go from there. I have an interval that goes from 0 to, oh my goodness, I have no idea, but it's there. And it's going to be 8x minus 1x. Yes, put 7x if you want, but for the sake of explanation, I'm going to do this. What I have just written, with the exception of this missing number up here, what I have just written is this piece, top minus bottom. Now we do the other one. I don't know where it starts. We'll find that out in a minute. But I do know it ends at 1, and it's top minus bottom. And the top function, the uppermost function, the greater function in this region is 1 over x squared. And then we subtract away the lower one, which is x. There we go. All right. So what I like to do often is jump straight to my answer or what I would do to get my answer and then see what I'm missing. And I'm missing this. And I probably didn't know that either until I started delving into it, right? So I need to know what this is. And I'm going to go a little calculator inactive on this one. And we're going to find it. And we find it by finding the point of intersection between 8x and 1 over x squared. So let's do it. So 8x equals 1 over x squared. We'll cross multiply. So 8x cubed equals 1. So x cubed is 1/8. And that means that x is the cube root of 1/8, which is 1/2. I've written it really tiny down there, but it's 1/2. It looks like a half, but we couldn't have assumed that. We need to figure it out. There we go. Let's not go calculator inactive on this. We could. We totally could right here. So you can type this straight in the calculator if you want. I'm not. I am going to do a little bit of slightly obvious work that's not necessary, but just so obvious that I'd hate not to do it. See? And then there's this one. So 1/2 to 1. Let me revisit something I said earlier. I think a lot of times people get stumped on what to do in a problem when I personally believe the best thing is to see what it's asking and then just start writing. Find the area of the region. Okay, fine, great. So area of a region, top minus bottom, and start writing an integral or two and see what you're missing. And then go back and fill in those pieces. That might come in handy. All right, so let's type this in. And I'm not going to type the functions this time like in y equals. I'm just going to go straight from there. And if you wanted to, you could do this one, second calc, and that. The lower limit is 0. The upper, no, it's not going to work. Not going to work. Sorry. Let me back away from that. If you do second and calc from here, and you do number 7, it's going to find the area between a curve and the x-axis, and we have to subtract some stuff out. So ignore what I said. I'm sorry. Let's do this. And we'll just type the whole thing in. Whole thing. Don't waste your time. There's that one, plus the other one. Just keep adding. So math, 9. We go from 0.5 to 1 of 1 over x squared minus x dx. I'm going to press enter and we're going to get an answer, and it is 1.5, and I find it fascinating that thing is curved and it still gives us an answer of 1.5. There we go. Okay, woo! Now we get some tricky ones here. I'm not going to draw this one much. I might a little bit. Find the area of the regions created by the graphs of this one, and I put this one in for a reason. I've really engineered this one to look a certain way. So y equals, and we're going to type them in. Let's clear out what we have. And let's see what we get. So 2.5 sine x. Close that parentheses. Whoa! Better close that parentheses because I wasn't done. Plus 0.2x. And here we have negative 0.2x and plus 1. Okay? So making sure I typed it right. I did. I'm going to zoom standard just to kind of get a visual for what it looks like. And as I read the problem while it's graphing, it says, find the area of the region or regions created by the graphs of this one and this one. And so there might be enough overlap to where I need to do this more than once. And it does happen. Okay. I hope you notice what's happening here. Clearly the red line has a negative slope, and the blue sinusoidal graph has a slightly positive trend to it. So here goes red down, here goes blue up, but they only intersect at 3 points. They intersect here, here, and here. And I don't know where those are, and I'll find them in a minute, and I cannot find them by hand. But I'm going to find where they intersect, and when I do that, all I really need to do is find the area of this piece and this piece, and nothing else. because they never intersect again, and they never really build these little boundaries between the two. Because from here on out, it's just one big open region, and from here on out, it's one big open region. So I'm going to draw it, not very well, but I'm going to draw it. So there's this, and there's this, and there's a crooked x-axis. And so there's this blue thing, and it goes like this, and it just goes through the origin. Oops. And then it goes like that, and it's kind of going up. And the red one goes down, and it does that. And so again, what I'm really finding, you don't have to draw it if you don't want to. What I'm really finding is that one and that one. And one more reason, one more explanation why I'm not finding anything else. If I was to color this in, where would it stop? I don't want to do that. Same thing here. Color it in, where does it stop? So it's these two. So I need to figure out what is, this is cool, what's top, what's bottom, and what my intervals are. And I don't know. So we're going to find it. So here, thinking ahead, and when I think ahead, I like to write things down. I have two regions. I have the interval from something to something, the integral from something to something, dx, and I have another one. And leave plenty of space because we'll probably write some stuff in there, okay? All right, what am I missing? Well, like everything. I don't know what I'm doing. Because I don't know what I do know what I'm doing. It's poorly worded. I know what I'm doing. I just don't know how to do it. So here goes. I need to know this point, and this point. I don't know what I'm going to fill in yet, but I know this point. I'm going to call it A. I'm going to call this point B, and I'm going to call this point C. Perfectly valid. Let's do that. This will be A. This will be B. That'll be B, and that'll be C. And if that made no sense, you'll see what I mean in a minute. All right, let's also figure out what's on top and what's on bottom. Okay, so in this case, the blue one's on top, which was the sinusoidal graph. That's this, that's F. So the first interval is, well, top minus bottom, which was F minus G. The second one is also top minus bottom, but now that it shifted, it changed from who's on, which function is the greater function, the one above the other one. So it's G of X minus F of X in this case. So now let's find A, B, and C. Go back to the calculator. We're going to calculate where they intersect, and we're going to enter on the first curve, enter on the second curve, enter on guess, and it gives me that one right there. And that is currently my X value, and it is 0.351027. I want it to be just exact as I can make it, so I'm going to press quit. And then I'm going to go X stores as A. Whoops, not plus anything. There we go. That's it. I'm going to write it down. I'm going to write it down in all its decimal glory just because. So A equals 0.35100272219. But from now on, I don't need to write that. I've defined it. So it goes from A to B, and I don't know where B is, and I don't know where C is, but we'll figure it out in a minute. So, all right, here goes. Second, in calc, I want to find where they intersect. So I'm going to get closer to the point that I'm looking for. Enter on the first curve, enter on the second curve, enter again, and 3.2641659. 3.2641659. Okay, now that's stored in my calculator as X. X changes. I told you X changes a lot. So we're going to quit, and X is now going to store as B. Boom, done. All right, let's find C. Same process. Intersection. Get closer to where they intersect. Enter, enter, enter. 5.7384891. Second quit. X stores to C. All right, we're ready to go. B, and C. All right, one more thing I want to check before I type this in. I want to make sure that F is Y1 and G is Y2. Otherwise, I'm going to have to switch the way I type it and think it. So, yeah, we're right. We got it. So, this one is going to be Y1. That one's going to be Y2. Just so I don't mix things up, let's write that down. That's going to be Y1. This is Y2. And this one, of course, is Y2. And that's Y1. We'll type it in and we'll get an answer. And the next problem will be in a different video because it's a very different idea. Well, oh man, pressed clear. the next one totally changes the way you think about graphs. It's awesome. A to B of y1 minus y2 dx plus math 9 B to C of y2 minus y1 dx. Takes it a minute. 6.661. There we go. 6.661 square units.